In our previous installments, we learned how to model the position and velocity of the block. Now it's time to model the acceleration. Here is our equilibrium position, and we have our maximum displacement at XO. And our minus XO over here. So accelerations are caused by forces. And so if we remember, there is a spring attached to this block. And so as we grab this block and pull it in this direction, we increase the force on the block. And as we increase the force, so will be the resulting acceleration. Another way to just look at that is to say that the force will be a maximum out here at the maximum amplitude, and that's therefore when the acceleration will be a greatest. So the maximum will occur at time zero. So at time zero, we have our acceleration at a max, and it is negative. It's headed in the negative direction, so it's a negative max. On our graph then, we have our acceleration. Here's 0. Here is the period. Here is 2 pi radians. And we start out at a negative max. Or this is minus A0. When we get all the way over halfway through the cycle, we see that it's then going to have an acceleration that is positive. It will be a positive max at the midpoint. And when it returns back to the original, again, the acceleration will be negative max. And so what we should recognize this as a negative cosine. So we have acceleration is negative A naught cosine omega t. And in the previous example, what we had said was when we took the first derivative of the velocity, we had v is minus xo omega sine omega t. Oh, excuse me, we didn't do the it's minus v0 omega cosine omega t. So we have negative v0 omega cosine omega t. And so that tells us then that A0 equals v0 omega. A0 is, the amplitude is v0 omega. And in the previous example, we also saw that v0 was x0 omega. So we have minus x0 omega times omega. And so A naught then equals negative omega squared x naught. Negative omega squared x naught. Now what I'll point out here is that this is basically saying that the acceleration is opposite and proportional, constant proportionality omega squared, to the displacement. The maximum acceleration is opposite and proportional to the maximum. The maximum acceleration is opposite and proportional to the displacement, which is the original definition of simple harmonic motion. Acceleration is opposite and proportional to the displacement.